Chapter 5. We are sure. With no concerns for maintaining appearances, Marie and Pierre have a simple fourth-floor apartment in Paris. Their furniture includes one table, 2 chairs, an oil lamp, and a bed. The modesty of their home keeps Marie's housekeeping chores to a minimum. The only accoutrements are a flower vase and books, particularly their physics books. Their low-maintenance lifestyle involves evenings spent seated at the table, studying, enjoying the fragrance from the flowers on the table, and a view of the trees outside the windows. On weekends, they ride their bikes to visit Pierre's parents. Marie's research measuring magnetic properties and Pierre's exploration of crystals is not interrupted. Dr. Curie has a room equipped for them to continue their work. Pierre is still teaching at the School of Physics, and even with his promotion to Chair of Physics, his salary is comparable to a factory worker. The illustrious Sorbonne is loath to ever hire Pierre. This same academic stuffiness denies him acceptance to the French Academy of Science. Not having membership, Pierre does not have access to their library, which includes current scientific papers, nor can he attend lectures or their social gatherings where the discourse with members would provide useful information. This barrier to information is akin to a researcher not having access to the internet today. Pierre's grueling schedule as a teacher includes preparing 120 lessons per school year on top of overseeing his students' experiments. His income is supplemented with consultant fees from a company that is using his equipment. Some of his tasks are made easier by kind people, such as the laboratory chief at the school, whose name is Petit, and is very devoted to Pierre. Marie will write, "This good man, whose name was Petit, felt a real affection and solicitude for us, and many things were made easier because of his goodwill and the interest he took in our success." Unusual for the time, Marie feels a sense of responsibility to help with finances. She writes, "I want to get my degree, and then I will look for work." Marie enrolls in a certification course to become a physics teacher. She will still make time for her research and attend classes on crystals in order to better understand Pierre's work. Marie and Pierre postpone a trip to Poland the following year in order for Marie to complete her certification exam. Marie graduates first in her class. Following Marie's teaching exams, Pierre and Marie take another bike tour of the coast and the countryside. With both having a knack of being absorbed and inattentive to time, there is no check and balance between the two of them. One afternoon, they realize they've stayed out too late, and they can't find their way back in the dark. Marie and Pierre have a lovely memory of the night they slept in a field with the cows. Marie's schedule is taken up with her research and writing. In the spring of 1897, she finishes her studies on the magnetic properties of steel. Writing an article about her research, Marie is recognized for her work when the article is published in a scientific journal. She continues her research and has permission to work in an area of Pierre's lab as long as she can cover her expenses. The balance of time for Marie's daily life is about to become even more strained. Adding to the daily itinerary are bouts of morning sickness. Marie is pregnant with their first child, and she writes to Kasia, "For more than 2 months, I have had continual dizziness all day long from morning to night. I tire myself out and get steadily weaker, and although I do not look it, I feel unable to work and am in a very bad state of spirits. My condition irks me particularly because my mother-in-law is now seriously ill. She's the one with incurable breast cancer. And then to her brother Joseph, Marie writes more of her concern, and she says, I am afraid, above all, that the disease will reach its end at the same time as my pregnancy. If this should happen to my poor Pierre, he will have a very hard time in the following weeks. The baby is due in September. Vladislav comes to France for the summer to be with Marie. He is renting a house on the coast. Marie and her friend Jadwiga, the umbrella fighter, are spending some time at the shore with Marie's father. For Pierre and Marie, it is their first time apart since their marriage. Their correspondence is full of touching sentiments. Pierre writes, I miss you very much. My soul has run off with you. Marie writes, I'm very sad without you. Come quickly. I wait for you from morning to night, and I don't see you coming. Pierre writes, I think of my darling who fills my life, and I would like to have new mental powers. It seems to me that if I concentrate my mind exclusively on you, as I have just done, I ought to be able to see you, to follow what you are doing, and also to make you feel that I belong to you completely at this moment, but I can't manage to get a picture. Not only is their love of each other entwined, but also their love of learning. Marie writes to Pierre, I work as much as I can on Poincare's book, but it's harder than I thought. I have to talk to you about it, and we have to look at it again together and see what has given me so much trouble. And their letters swing back to the practical family matters. Pierre writes to Marie about his progress tracking down special baby clothes and supplies. It is entertaining to see diapers are the topic of new parents in any era. While today it is the expense of disposable diapers, for Marie and Pierre, they discuss a diaper pattern. There is something beautifully sincere reading about two brilliant scientists who can measure minuscule levels of electricity while they are genuinely wondering what the right measurement of a diaper should be for their baby. Marie must balance her roles in life. Work, wife, woman, and now mother is added to the list. Marie, as work, is still studying. Marie, as a wife, and Pierre want to go on a bike ride. Marie, as a mother, is 8 months pregnant. Marie, as a woman, wants to show society and herself she is free to ride a bike, pregnant and in public. While they are still at the summer house, Marie and Pierre are out for a ride on their bikes. Marie goes into labor and is rushed back to Paris. September 12th, 1897, Pierre and Marie have their first child, a daughter. Her name is Irene. Dr. Curie, Irene's grandfather, is the one to help bring Irene into the world. Irene, forever close to her grandfather, will only have a grandmother for 2 more weeks. Marie is up during the nights and comes home at lunchtime and dinner to nurse Irene, whom she calls my little queen. Irene is not gaining enough weight, and Marie is exhausted and worried. A visit to the doctor shows there is a lesion on Marie's left lung. With this early sign of tuberculosis, the doctor suggests Marie visit a sanatorium for several months. It's hard to imagine how Marie must have felt, remembering her mother with this diagnosis, going off to a sanatorium, missing her children, and she died. Marie chooses to ignore the doctor's suggestion. One concession Marie makes is to hire a wet nurse for Irene. Marie writes to her father, in spite of the sorrow it causes me and in spite of the expense, I wouldn't for anything in the world to hurt my child's development. During these months, Dr. Curie comes to live with them. Marie can relax knowing Irene is in the constant care of her grandfather. The routine becomes Marie feeding and dressing Irene in the mornings, and in the evenings she bathes, feeds, and puts Irene to bed. In the evenings, Marie makes notes in a journal of the date Irene first rolls over, holds an object in her hand, and when Irene starts calling her May, which is, for ma or mom. Any other free time, Marie is sewing clothes for Irene. It's Marie's opinion that ready-made clothes are too expensive and fancy. As an aside about Dr. Curie, Dr. Curie is not an additional burden at the house. He cares for Irene and helps with household duties, freeing Marie to continue her research. Dr. Curie is a striking example of a man stepping away from traditional male roles in 1897. The general opinion of society would agree that Marie should not push for having a professional life any further. In fact, Marie would have heard a sigh of relief from society if these had been her sentiments, as if these were, saying, "I have done enough. I am the first woman to have not 1 but 2 degrees from the famous Sorbonne. I have a wonderful husband and child. I will work as his assistant, teach at the girls' school, and just be happy." These are not Marie's words. She wants more. Marie wants to earn a doctorate in physics. Marie's decision of what to study for her doctorate is first broken down between 2 choices. If Marie leans toward advancing early discoveries, she will spend the bulk of her time reading scientific papers. If she pursues new discoveries, Marie can start immediately with research. Never a better example of follow your heart. Marie opts for the path of research, pursuing new discoveries. And again, as an aside, about the book itself, this book. Scientific descriptions written in this book are for the purpose of portraying the tenacity of Marie's character and brilliance. While the descriptions are accurate, they are minimal, and they are not meant as a go-to science reference. Back to the text. Before we see where Marie's decision leads, a few details for the context of science during this era will help readers comprehend, then, the magnitude of Marie's work. So here we go. An invisible light has been discovered 3 years earlier by Wilhelm Röntgen. He's in Germany, and this is 1895. Using the term X, because X stands for unknown, these light rays will be called X-rays, and the name sticks. X-rays are shocking the science world. The X-ray beams can penetrate tin, paper, rubber, even wood. Only lead is capable of not having an X-ray pass through it. Röntgen is passing around an X-ray photo of his wife's hand, and everyone can see the ring on her finger. The picture of Mrs. Röntgen's hand goes viral and becomes the most famous photograph in the world. German Kaiser Wilhelm presents Röntgen with the Order of the Crown. X-rays are the ballyhoo of possibilities and become part of the pop culture. X-rays are the subject of cartoons, and there are jokes of husbands spying on their wives through locked doors. X-ray opera glasses are sold with the purpose of being able to see through costumes to the naked bodies of the actors. X-ray proof suits are available for businessmen in London who are worried someone will use X-ray glasses on them. And in New Jersey, they are considering a ban on X-rays to prevent lewd possibilities. Within the next year, 50 books and 1,000 papers are on X-rays. A magazine in England claims, quote, "You can see other people's bones with the naked eye. On the revolting indecency of this, there is no need to dwell," end quote. Misinformation runs rampant. The Purity League in the United States proposes a law that theater goers be banned from using X-rays in their opera glasses. X-ray proof corsets better known as modesty gowns, are being sold in clothing stores. As an aside, this influence on pulp culture continues into the 1930s. Superman's X-ray vision can't see through lead, and the mysterious substance kryptonite has power that can be neutralized only when sealed in a lead box. Back to the text. Industry quickly puts X-rays to work. 2 weeks from the discovery, X-rays are used in the United States to locate a bullet in a patient's leg. Just in time for Marie, the X-ray discovery is a wake-up call to the world of physics that had put the subject afloat on the backwaters of science. Another piece of groundwork and person to know before we get back to Marie, and that would be Henry Becquerel. He's described as arrogant and entitled and is a fourth-generation scientist. His family has money, which enables Becquerel to have a fully equipped laboratory and the pleasure of changing his starched shirt twice a day. His character is opposite from the Curies, but their paths will cross. Becquerel's father had studied phosphorescence, which is light emitted by a substance without combustion or perceptible heat. And he invented the phosphoroscope. Becquerel has decided to see if there is a link between X-rays and phosphorescence. Becquerel, in a series of experiments, discovers another type of penetrating ray when he is using uranium salts. The rays from the uranium salts he refers to as Becquerel rays. Becquerel has also discovered that rays from uranium cause the surrounding air to conduct electricity. This electricity is actually ionizing the air, and this is what causes a Geiger counter to click. He publishes 6 papers on the subject. Becquerel does not try to explain the source of these new rays. He has bumped into the edge of his understanding. Thinking nothing more can come of it, he drops the subject. What Becquerel drops, Marie picks up. Marie decides her doctoral studies will be to further explore Becquerel's recent experiments with X-rays and to better understand the source of the rays coming from the uranium. Marie hopes, quote, to determine the intensity of the radiation by measuring the conductivity of the air exposed to the action of the rays, end quote. Marie will also see if other elements give off these same rays too, which is similar to her previous work studying different elements to see which ones are magnetic. What begins with the goal of measuring will turn the world of physics upside down. Marie starts work December 16, 1897. We know this because it is the date she writes in her research journal. It is touching to see that the journal is one given to her by Pierre. The first few pages of the journal are actually his notes. To measure the strength of the rays, Marie needs equipment capable of measuring weak electrical currents with great precision. Where will she find that? It's the electrometer that Pierre and Jacques had built. Pierre takes time from his own research on crystals and works for 15 days to modify the electrometer for Marie to use. He makes sure Marie also has piezoelectric quartz. Marie needs this because it measures in absolute terms small quantities of electricity as well as electric currents of low intensity. Marie spends 3 weeks learning and perfecting how to use the piezoelectric scale. Henry Becquerel had tried to use this equipment and had given up. The scale is so sensitive, a fingerprint can change the reading. The steps for working the equipment are a precise synchronization of the scientist's movement. The body must sit perfectly still and the eyes stare straight ahead at a plate glass. While doing this, the right hand places weights on the scale of the equipment and the left hand holds a stopwatch to keep track. As an aside, years later, Marie's granddaughter, who is a French nuclear physicist, Helene Langevin-Joliet, is asked to give a demonstration on how to use the piezoelectric scale, and she responds, "Impossible. No one at the Institute has the sleight of hand or the concentration to do it. In fact, I know of no one alive who has this skill." Back to the text. Marie's supplies include wire, glue, wood, crystals, tin, and glass. If Marie needs more glass beakers, she makes them herself. Marie will also need to use the new invention, vacuum tubes. Marie and Pierre make their own vacuum tubes with a hand pump to extract the air. Pierre helps Marie have space to conduct her research. He convinces his boss to let Marie use a storage area that is full of old equipment and piles of lumber. Marie is happy to have a place to work, although the room has no heat, and in February she writes in her notebook that it's 44 degrees, that would be Fahrenheit, or 6.25 degrees in Celsius. That's pretty chilly. In her journal entry, she adds 6 exclamation points. Marie doesn't care about the temperature for the sake of her comfort. What she cares about is that the cold will affect her equipment and the measurements. Marie is borrowing mineral samples from colleagues and from the collection in the Museum of Natural History. She tests each element to see if any rays are emitted, and she measures the rays. Her next step is what indicates her brilliant mind. Marie retests the elements that emit rays to see if the energy is different while the element is in the liquid or solid states or being exposed to light or heat. The fact that these tests show there is no change in the rays emitted or the energy level of the rays, even when the conditions change, leads to Marie's shattering discovery. Marie states that the ability of some elements to give off the rays is a characteristic of the atom itself. It's an atomic property. Although Marie becomes most famous in the general public for her discovery of radium, what sets the world of physics agog is her declaring that atoms have properties. No one in the science world has considered this possibility. The impact of this finding, an atom having a characteristic, is the shot heard round the world in the science domain. Atoms were previously seen as being a simple, solid ball. Marie is questioning a 2,000-year-old scientific belief. As an aside about the history of atoms, everyone believes the makeup of an atom is exactly what the word atom indicates, indivisible. Ernest Rutherford, the father of nuclear physics, will be a 1908 Nobel Prize in Chemistry, said, "I was brought up to look at atoms as a nice hard fellow, red or gray in color, or according to taste." As far back as 460 to 370 BC, Democritus had stated the atom was the smallest part of matter and could not be broken down further. In 98 BC, a poet described an atom as the only eternal and immutable entities of which our physical world is made. James Clerk Maxwell, a mathematical physicist from 1831 to 1879, he writes, "Though ancient systems may be dissolved and new systems evolved out of these ruins, the molecules, atoms, out of which these systems are built, are the foundation stones of the material universe and remain unbroken and unworn. They will continue to this day as they were created." So back to the text. Aside from the belief the atom is the least common denominator, there is the law of the universe stating that energy cannot be created or destroyed. Matter is believed to be inert. This is brought into question by Marie's work, studying these rays with their unknown energy source. It's as if a light bulb is sitting on a table by itself and giving off light. So it appears these radioactive substances are radiating with no understandable energy source. Because at that time, the gradual deterioration of the element, its half-life, they don't know that yet. What the best scientists in the world have believed is being challenged by a woman. Ugh. Coinciding with Marie discovering atoms having properties, Marie discovers that thorium also has the trait of emitting rays. And this quality, the ability of an element to emit rays, needs a name. Marie calls this characteristic radioactivity. Pierre, still teaching at the school, has no laboratory and conducts his research in a corridor of the school. When the chemistry physics chair is available at the Sorbonne, Pierre, being the most qualified candidate, applies for the post. This position would not only double his salary, more importantly, Pierre would have access to a lab. The Sorbonne, stubborn with stuffy standards and the unspoken priority of pandering to the self-importance of their boys' club, selects a lesser qualified candidate. Keeping Pierre free of this new position will be to the Curie's advantage, but at the time, the game of backdoor politics is quite disheartening to Pierre. Marie's recent discoveries are creating more questions about radioactive elements. Therefore, she stops work on all other inactive minerals, and concentrates on the radioactive ones. After testing and concluding that only uranium and thorium are radioactive, Marie is testing a uranium ore known as pitchblende. There's about to be another shakeup to science. Knowing how much uranium is in the sample of pitchblende, Marie should know how much radioactivity will be measured. The level of radioactivity that registers literally doesn't add up, though. The level far exceeds what can be accounted for with the uranium. Marie measures and measures again. The results keep showing an additional level of unexplained radioactivity. Marie knows that chemists have analyzed pitchblende and they have accounted for 99% of the minerals found in it. Marie realized there must be a new radioactive element in pitchblende, in that unaccounted for 1%. That is making the increase in the reading. She also knows this new element must be extremely radioactive since it is giving off such a high level of radioactivity for such a minuscule amount of pitchblende. At this time, when other scientists are busy in the race to discover the elements that will fill in the gaps of the periodic table, Marie has come upon a new element in the midst of her researching radioactivity. Frederick Soddy, who worked with Ernest Rutherford and later exclaimed that radioactivity is due to transmutation of elements. He writes of the Curies, quote, Pierre Curie's greatest discovery was Marie Sklodowska. Her greatest discovery was radioactivity, end quote. Marie's new method of discovering elements by measuring their radioactivity is what leads to more discoveries about atoms and their structures. Marie writes, these minerals would have had nothing astonishing about it if it had been in proportion to the quantities of uranium or thorium contained in them. But it was not so. Some of these minerals revealed an activity 3 or 4 times greater than that of uranium. I verified this surprising fact carefully and could not doubt its truth. Marie even later writes to Bronia, the radiation from the pitchblende that I couldn't explain comes from a new chemical element. The element is there. I've got to find it. We are sure. Marie uses the word we because Pierre has joined her. With the Sorbonne snub and the recent revelations by Marie, she writes, he abandoned his work on crystals to join me in the search of this unknown substance. With this decision, Pierre risks his reputation and losing the edge he has as the lead expert in crystals. For the next 8 years, their work melds in collaboration. The entries in their notebooks always reads, "We found," or "We observed." By March 1898, Marie establishes that several minerals give off more energetic rays than pure uranium. The Curies develop a method of chemical research that separates out other elements from ores such as pitchblende. Each element is measured to see if there is any abnormal activity of radioactivity. In this process with pitchblende, they realize there is now not just one new element, but there's two. Marie's colleagues tell her she has made a mistake in the experiments, and they suggest to her to be more careful. The Curies are sure there is no mistake. How to find this new element? The genius of Marie is her idea of finding the unknown substance by looking for the rays to be different than the rays of substances that are known. Marie writes, "As we did not know at the beginning any of the chemical properties of the unknown substance, but only that it emits rays, it was by these rays that we had to search." Marie writes a paper in April that will establish the method of discovering new elements by measuring their radioactivity. The paper is presented to the Academy of Sciences by Gabriel Lippmann, Marie's former professor and mentor. Marie and Pierre are not members, and only members can present papers. Entitled, "Ray Emitted by Compounds of Uranium and of Thorium." The paper is printed within 10 days and is circulating throughout the scientific community of the world. And the paper reads, quote, "It was necessary at this point to find a new term to define this new property of matter manifested by the elements of uranium and thorium. I proposed the word radioactivity." End quote. This is the beginning of the new field of atomic science. 3 game changers in this paper are Marie stating that radioactivity can be measured. 2, to use this measure as a means to discover new elements. And 3, that radioactivity is an atomic property. When Marie is lecturing, she acknowledges that radioactivity might be a unique chemical reaction that defies the principle of the atom being indestructible. She suggests that, quote, "This hypothesis strikes just as serious a blow at accepted ideas in physics as the hypothesis of transformation of elements does at the principle of chemistry, and no one can see that the question is not easy to resolve." End quote. Marie has subtracted out every element except bismuth, and when she starts eliminating that, the sample is 150 times more active than uranium. While working in the lab, Pierre is heating a solution of bismuth sulfide, and the glass test tube cracks. Luckily, Pierre doesn't cuss and throw away the damaged tube. Instead, he notices a thin layer of black powder on the tube, and he measures the radioactivity of the powder. It measures 330 times more active than uranium. As they continue to extract any remaining bismuth from the powder, it leads to stronger results. I compare it to like making a reduction sauce. As you boil away more liquid, the flavor is stronger. Back to the text. This is their discovery of the new element. Marie names the new element polonium after her home country, Poland. Marie and Pierre have prepared a joint paper to be presented to the Academy of Sciences. This time it is presented by Henry Becker. The title is "On a New Radioactive Substance Contained in Pitchblende." The paper announces the existence of the new element. And it says, "We propose to call it polonium from the name of the country of origin of one of us." End quote. Marie has not lost her edge of humor. She knows that her research will be published and read in Russia, Germany, and Austria. These occupiers of her country will be reminded there is still the dream that Poland will someday reclaim its independence. Marie sends a copy of her papers to her cousin in Warsaw, Joseph Bokuski, who at first opened the doors of a laboratory for Marie. C's encouragement to Marie was certainly not in vain. The difficulty for the Curies is in identifying and quantifying the energy of a radioactive element. Marie calls it, quote, the chemistry of the invisible, end quote. Taking a creative leap, Marie doesn't rely on the usual means of verifying a new element, which is weighing the sample to find its atomic weight. Marie's samples are too small, 1,000th part of a milligram. Marie must use a different means of proving the existence of a new element, seeing a new spectral pattern. What is known is that when heat is applied to an element, the result is a spectral pattern. This pattern, like a fingerprint for an element, is different for each element. Seeing a new pattern will be the means of identifying a new element. By measuring the rays that the sample emits, Marie is able to weigh it. An expert in identifying spectral patterns is Eugene Demarquay. The Curies have brought to him several samples in hopes of identifying a new spectral pattern. These samples had not been pure enough, so no new pattern was shown. Finally, Marie brings another sample, and through his spectroscope, Demarquay sees a pattern he has never seen before. This is the proof Marie needs. The previous paper presented in June at the Academy was a preliminary step, like announcing an engagement. Having the evidence of the spectral line makes it definite. July 18, 1898, Marie can officially name the new element polonium. By December of the same year, another new element is identified. Marie names this radium. It is the most powerful radioactive substance ever discovered. This same July, the Academy of Sciences is impressed with Marie's prior work on magnetic properties of steel and now on radioactivity. The Academy awards Marie the Geiger Prize with 3,800 francs, which in 2015 was equivalent to about $1,267. The award is for the precision of the procedural methods of Madame Curie. Recognition of a woman's achievement only goes so far. As a means of continuing their stance to not acknowledge women, the Academy doesn't directly notify Marie. Instead, they tell Pierre and ask him to inform her. Becker also speaks only to Pierre, and he says, I congratulate you very sincerely and beg of you to present my respectful compliments to your wife. Recent discoveries have moved Marie and Pierre forward. However, a setback for Marie is Bronya and Casimir's return to Russian-controlled Poland to start a new sanatorium for tuberculosis patients. Marie, bereft at this loss, writes to Bronya, you can't imagine the hole you have left here. When I lost you two, I lost everything. Everything I care about in Paris besides my husband and my child. Now I feel as though Paris doesn't exist outside of our house and the schoolwork where we live. Marie goes on to ask Bronya for advice. She asks, ask Mother Luska if the green plant you left here should be watered and how many times a day. Does it need a lot of warmth and sunlight? And then she fills Bronya in on the latest news of Irene. She writes, Irene is turning into a big kid. She is very difficult to feed, and except for tapioca pudding, she will eat almost nothing regularly, not even eggs. Write me what sorts of food children of that age should be eating. Marie and Pierre visit Bronya and Casimir. This occasion becomes a family reunion that includes Vladislav and all Marie's siblings. Joseph is a medical doctor with his wife and children, Bronya and Casimir with their 2 children, Hella, a teacher, and her husband, who is a prosperous businessman in photography. Pierre tells Marie in Polish, "This country is very beautiful. I understand now why you love it." It will be the last time they are all together with their father. For Pierre, there is more professional disappointment that year. Pierre's work on crystallography, piezoelectricity, symmetry, and magnetism are well known. Add to this his work with Marie discovering radium and polonium. One would think this garners the attention of the Sorbonne. When a chair in physical chemistry becomes available in the winter of 1898, Pierre is again the obvious choice. He might be obvious, but he is not the choice. An opinion here for why Pierre is also not selected is his well-known acknowledgement support for Marie, and this not playing by the boys' club rules is possibly also partly why Pierre is kept out, because he will not acknowledge and keep, because he always acknowledges Marie's help and doesn't keep her at a distance. So, they're not really interested in that. Back to the text. Aside from needing to isolate the new elements, the other question is, what is the source of this energy? The Curies record that the radium gives out heat in large enough amounts that it can be measured by their simple laboratory techniques. Marie, after a series of experiments, writes, "No change occurs in this material which radiates the energy." So that would be like a piece of wood that just keeps burning and stays a piece of wood, doesn't disintegrate at all into ash or anything. They just don't understand it. Back to the text. This undetermined energy source is breaking the basic law of physics. The law of conservation of energy states that energy can neither be created nor destroyed. So if heat energy cannot be created, where is it coming from? Marie proposes either the radioactive substances are borrowing the energy from an external source and then releasing it, or that the radium is the source of the energy itself. As an aside, the Curies had initially believed that something outside the element is causing the energy. Rutherford believes the answer is within the atom itself. Rutherford will be right. The radium and polonium are gradually breaking down, decaying, and that process is the change that causes the atom to give off rays. Hence, the law of conservation of energy stays intact. Back to the text. As the enigma of radioactivity is being unraveled, another question is, why are some elements radioactive and others are not? Marie's answer will eclipse her discovery of polonium and radium. Marie continues her train of thought from radioactivity being an atomic trait to realizing this is an atomic process. December 26, 1898, the Curies are getting one last paper in before the turn to the new year. The paper to the Academy is presented by Becker, and it will be published in a scientific journal. The Curies make the official announcement of radium. Quote, "A new, strongly radioactive substance contained in pitchblende," end quote. The results are supported by Desmarques's report that there is a unique color on the spectral line known to no other substance. Marie, happy with her life, writes to Bronya, "I have the best husband one could dream of. I could never have imagined finding one like him. He is a true gift from heaven, and the more we live together, the more we love each other." And that ends chapter 5. Thank you.